Okay, let's start the class. Hi guys, welcome to NEET World Institute and NEET World YouTube channel. So in this class we are going to concentrate on the class 12th IPE. So the lesson name is Semiconductor. So in this you will get 4 mark questions, okay. So that is short answer questions, right? No, short answer questions. So let's go into the topic. The first question of this class is distinguish between Zener breakdown and avalanches breakdown, right? So there are two things we need to compare. The first one, this occurs in heavily doped diodes, right? Yeah, this occurs in heavily doped diodes and this is light doped diodes, okay. So two difference, heavy doped and light doped. It occurs at low reverse bias voltage, here high reverse bias voltage. Reverse bias is the common term, but it is low and it is high. But when I talk about doped and low doped, no, so here high doped and here low doped, okay. Here low reverse bias, here high reverse bias, and this occurs due to field emission, and this occurs due to ionization by collision, field emission, ionization by collision. And fourth point, it gives the discontinuous and pulsative DC output, okay, pulsative DC output, discontinuous and pulsative DC outputs. But whereas it gives continuous and pulsative DC output, it discontinuous, here continuous. So both are positive DC outputs, okay. So this is the difference between these two breakdowns, okay. You can take a note of this and we can go for the next question, right? Yeah. So once note down this and we can go for the next question. Got it? Done? Can we go for the next question? Okay, fine. So yeah, the next question is describe how a semiconductor diode is used as a half wave rectifier, okay. So first we will see the construction of this. So construction of this half wave rectifier can be constructed with a single diode, and let me tell you, we will construct with a single diode and load resistance, right, and a transformer, load resistance, transformer and AC input, right. So these are the things we will use for constructing the half wave rectifier, okay. The DC output is obtained across the load resistance and the circuit is shown in the figure. This is the circuit, okay. So what are the things is there? Single diode is there, yes, single diode is there, resistance is there and transformer is there and AC output is there, input is there, okay. These are the 4 things we will use for this constructing the half wave rectifier, right? No, half wave rectifier. Now if we see the working, no, first of all, half wave rectifier which rectifies only either positive or negative half cycle of the AC output is called as half wave rectifier, right. So construction we know, and what is the meaning of half wave rectifier also we know. A rectifier which rectifies only either positive or negative, right now. So either positive or negative half cycle of AC input called as half wave rectifier, right. So when I talk about a working no, so the AC voltage across the secondary winding, right? No, secondary winding, like first winding and secondary winding is there, right? Yeah, secondary winding AB changes polarity after every half cycle, like it changes polarity. When it goes positive off, it changes the polarity. When it comes to second negative off, it changes the polarity. During positive off cycle, the diode is forward biased and current flows through the diodes. And during negative off cycle, like positive off cycle, what happening? Forward bias and current flow through the diodes. And during the negative off cycle, what happens? The diode is reversed bias and current does not flow through it. So for the positive off cycle, current flow and it's a forward bias, and negative off cycle, current doesn't flow and it's a reversed bias. So thus the current flow through the diode only during positive half cycle, and current flow in R1, I mean resistance only in one direction, okay, R resistance in only one direction. Hence half wave rectifier gives discontinuous and plus stative DC output across the load resistance, okay. This is the output. If you see here, this is the output. So the input was given, but when it completed and gave output, no, only half wave will be there, okay. Only in positive it is a forward bias and current flow, and in negative there is no current flow and it's a reversed bias, right? Now, yeah, you can take a note of this and we can go for the next question. Completed? Okay. So the next part, yeah, you can take a note of this and we can go for the next question. Okay. So yeah, the next question is, what is rectification? Explain the working of a full wave rectifier. So first of all, the meaning of rectification is nothing but the process of converting an AC, that is alternating current, into a direct current is called as rectification, okay. So the process of converting AC to DC is called as rectification, got it. And what about full wave rectifier? A rectifier which rectifies both off cycle of AC input is called as full wave rectifier. In previous case, what happens here? Here we have talked about, here we have talked about only positive off cycle which has been converted, which means it's a half wave rectifier. Now both positive and negative wave we will rectify that. Here what is the thing? Yeah, the rectifier which rectifies both positive and negative, like both off cycles, is called as full wave rectifier. Got it? So in previous case only positive we will get, in negative we won't get, but in here both positive and negative we will get. And what is the construction for this? So a full wave rectifier can be constructed with two diodes. If you see here, one diode and second diode is there. In the previous case only one diode, right? So center tap transformer, load resistance and AC input. Okay, here only one thing, one more diode is added, that's it. And in center tap transformer, no, the secondary coil is wounded into equal parts. So voltage at A and B with respect to the center tap are out of phase with respect to each other. Okay, so the main thing, like we need to write what we need to use to construct that material. Okay. Got it. Now working principle, if you see, yeah. So during the positive off cycle, AC input diode D1 is forward biased and D2 is reversed biased, and the diode D2 will not conduct any current flow. D2 will not conduct any current flow, and the load resistance R1 due to D1. And when similarly during negative off cycle, no, D2 is forward biased. Here what is the thing? During positive off cycle, D1 is forward biased. During negative off cycle, D2 is forward bias and D1 does not conduct any flow of current. Okay, here D2 is not conducting any flow of current, like it's a reversed bias. D2 is not conducting any flow of current, and D1 is a reversed bias here, and D1 will not conduct any current. Got it? Hence the current flow through the load resistance during both off cycle will be in the same direction. So therefore using full wave rectifier, the output is continuous but fluctuating as shown in the given figure. If you see here, I will show the thing. Yeah, if you see here, when positive off cycle gives a positive, yeah, and negative off cycle also positive output. When positive off cycle is there, it's a forward bias, and the negative off cycle will, second one will be a reverse bias, like D1 positive, D2 negative. So forward bias and reverse bias. When D2 is positive and D1 is negative, D2 will be forward bias and D1 will be reverse bias. So whenever they are calling the reverse bias, no, there will not be any flow of current. Got it? Okay. You can take a note of this, and we can go for the differentiate between the full wave and off wave rectifier. Okay, you can take a note of this first. Construction and working principle. Done? Okay. So the next question is distinguish between off wave and full wave rectifier, right? So so half wave rectifier, only half cycle of AC is converted into DC, whereas full wave rectifier both cycles of AC are converted into DC, right? Here only half cycle, here both cycles, got it? Only one diode is used, two diodes are used. Diode, if you see only one diode, there two diodes. Its efficiency is eta is equals to 0.406 R1 divided by RA plus R1, whereas here 0.812 R1 divided by RA plus R1. Okay, it gives discontinuous and pulsative DC output. It gives continuous, here continue, here discontinuous. Okay, and the number of DC output pluses is equal to the frequency of AC output. The number of DC output pluses is equal to the twice of the frequency of AC output. Okay, because it gives both the thing, no, here it gives only one thing. So these are the difference between the half wave and full wave rectifier. It's an important question, you can take a note of this. Okay, it's an important question. Okay, so the next question is, what is Zener diode, and explain how it is used as a voltage regulator. First of all, the Zener diode is nothing but a properly doped PN junction diode. Okay, it's a doped PN junction diode which has a sharp breakdown voltage when operated in reverse bias condition. Okay, what is the thing? A proper PN junction diode which has sharp breakdown voltage when operated it in reverse bias condition. Okay, so Zener diode and voltage regulator, like Zener diode as a voltage regulator, how we can use that one? So advice used to give constant voltage output, no? Okay, voltage output even when the input of voltage changes, called as voltage regulator. Okay, it gives the constant voltage output. If you see, like a voltage regulator we will be used in refrigerator, AC, everything, no? Yeah, the same thing, a device used to give constant output like voltage output even when the input voltage changes is called voltage regulator and or voltage stabilizer. Okay, so Zener diode can be used as a voltage regulator when operating in the breakdown region in reverse bias condition. Got it? The same point, right? Same point, like it's used in a reversed bias condition, then only we can use as a voltage regulator. So how we can construct that? So an unregulated input voltage, series resistance and load resistance and a Zener diode are connected as shown in the given figure. If you see here, we have taken a Zener diode like resistance, series resistance, load resistance. Right now it's a series resistance, it's a load resistance. Got it? And if you see the working principle, no, if the applied input voltage is greater than the Zener diode is in the breakdown condition, and the diode draws large current from the input through the series resistance. Okay, and what happens here, if I is the input current and IZ and I1 are the Zener and load current, IZ is Zener current, I1 is load current respectively, then I will be equal to IZ plus I1. Okay, this about the current, this about the current. So yeah, the next part, if you see, the current we have seen now, V in is equals to IR plus VZ, but V out is VZ, right? So what is V out? V out will be V in minus IR. So the value of R is selected in such a way that in the absence of load resistance, the maximum safe current flow through the diode. Okay, flow through the diode. If an input voltage varies, the series resistance R control, like input voltage varies, series resistor R controls the output voltage fluctuation, so as to maintain the constant voltage even when the load resistance R1 varies. Okay, so when the load resistance increases, no, but the applied input voltage is fixed. It increases also, applied input voltage is fixed. So the current I1 decreases and the current Zener current, IZ is increases, okay, by equal amount, so that the total current remains constant. So one decrease also, other one increases. So hence the output voltage remains constant. Output voltage remains constant. This is property of Zener diode. So whatever thing, it's a Zener voltage. IZ is nothing but Zener current. Okay, Zener diode which works as a voltage regulator. Got it? You can take a note of this and we can go for the next question. Completed? Done? Okay, we can go for the next question. So explain the operation of NOT gate and give its truth table. Okay, so this is the one of the easiest question, right now. So if you see here, a NOT gate is a device which has only one input and one output, only one input and only one output. So the NOT is represented by the bar like symbol. Okay, like when I take A, no, what is the NOT symbol of A? It is A bar will keep. Okay, so an expression is A bar indicates the Q is not equals to A. Q is not equals to A. So Q is equals to A. How we can write Q is not equals to A in the sense I can't write like this, right? So how we need to write Q is equals to A bar or A. Right now it denotes that Q is not equals to A. So when the input is low, the output is high. When an input is low, output is high. Why? Because like I can't say it's equal. Na? If input becomes low, output becomes high. When input becomes low, output becomes high. Right? Input high, output low. Got it? So when the input is low, output is high. When the input is high, output will be low. The truth table of NOT gate in terms of low and high is given here. Right? We'll see here now. So input low means output high. Input high means output low. So how we can mention in terms of number? 0 if we take, output will be 1. If we take input as 1, output will be 0. Got it? So whenever we are writing no AND gate, nor OR gate, whatever. So if you are writing like this, right now, or if you are writing like this, it's not a NOT. If we add a symbol, a small bubble in front of that, it's a NOT, right now. So the circuit symbol used for NOT logic gate, NOT is shown in the given figure. That is, if we take a symbol, circle or bubble in front of that cone, triangle, it will be a NOT gate. Okay, the circle of vertex of a triangle represents the inversion. Okay, it represents inversions. So this is about the NOT gate. Got it? Yeah, you can take a note of this and we can go for the next question. Got it? Okay. Can we go for the next question, guys? Finished, na? Okay. So the next question is, defined NAND and NOR gate. NAND gate and NOR gate. So AND gate and OR gate is there, no? So instead of AND and OR, we are representing a circle in front of AND gate and OR gate. It become NAND and NOR gate. Got it? So how we can write as NAND gate is the AND gate followed by NOT gate. Okay, AND gate followed by NOT gate. The output of AND gate is connected to the input of NOT gate. Okay, input of NOT gate. So in NAND gate, no, the output becomes 0 only when the input are 1. Only input are 1. So the symbol, if you see for the NAND gate is, it's represented by a symbol D. Okay, so in front of D, no, the bubble should be there. Okay, it's an AND gate. So triangle means it's an yeah. So if you see here, A B 0 0 and this is 0 1 and this is 1 0 and this is 1 1. So if you note down here, na, it's AB in the sense 0 0 0 0 1 0 1 0 0 1 1 is 1, right? When the output becomes, total output becomes 1 means it becomes 0, right? It becomes 0. Got it? So input we have given, input, this is input only. Okay, this is not output, this is input of both A and B. Okay, output, what output it will be? I'll get for AND gate, only AND gate. Okay, what I'll get here? 0 0 0 1, but this AND gate. Okay, this is NAND gate. So what I'll get here? 1 1 1 0, like a reverse of that. Okay, so this is about the NAND gate. So NOR gate, if you see here, NOR gate is the OR gate followed by the NOT gate. OR gate followed by a NOT gate. So the output of OR gate is connected to the input of NOT gate. Output of OR gate connected by the input of, yes, NOT gate. In NOR gate, no, the output becomes 1 when both the inputs are 0. Both the inputs are 0. Here if you see, like both inputs are 1, it becomes 0. Both inputs are 1, it becomes 0. Both inputs, output is 0. Here, yeah, both 1 when both inputs are 0. Got it? If you see the table, no, yeah, this is not output, this input of both A and B. So A, B, 0 0 0 1 1 0 1 1. So output for this one will be 0 1 1 1 1 1, right? Now what happened? Output of NOR gate, na, we are talking NOR gate 1 0 0 0. Got it? This is about the input and output of AND gate, NAND gate, OR gate and NOR gate. Got it? Yeah. I hope you got the answer for this question. Okay guys, with this I'll complete the session of today's semiconductor. Okay, and we'll meet in the next class with the next chapter. Thank you guys. We'll meet in the next class. Bye bye.